Okay, here we are. I'm almost done with the tie. It took me 5 points. Notice they're all labeled right there. By the way, the points, I eyeball them. That's how I get them on there. I look at my image and I kind of look at to see where I could place a point to make a line, so they're eyeballed. Once I have my points, I go through the process that I explained in the second tutorial video to on how to make the lines, and then I restrict the domain so that the lines don't keep going on forever. What I want to do right now is just spend some time talking about some of these parameters, or some of these the values that change the characteristics of a line. And so for let me save this right here. For that, I'll quickly open a new blank graph here, because I want to talk a little bit about what a line has. So I'm gonna say y equals mx plus b. And notice when I use variables instead of numbers, so for m, instead of actually putting a number, I put a variable m, and then for b, the y-intercept, I also put a variable. And it tells me here, add a slider for m, b, or all. Meaning if I put m, it's gonna add a slider for just m. If I do b, it's just gonna do it for b. But if I put all, it's gonna do it for both. And what this does is now my slope, m, can be changed by dragging this up and down. Now the reason I want to do this is because I want to show you what happens when you increase your slope. So suppose we have a slope of 1. You see that line? What increasing the slope does is it makes the line steeper. Notice how 2 is steeper, and you can see it get steeper and steeper and steeper as I keep increasing the slope. If I increase it all the way to 10, it gets really steep. Now I'm not restricted to 10. Notice the slider only goes up to 10, but I could actually put in a value here. I could put it like 50, and it's really steep. If I zoom out, it's a little hard to see, but it's very steep. I click home there. So increasing the slope makes my line steeper. That's what it does. And I want you to, the reason I want you to understand that is because sometimes maybe you don't get the line quite right. And you're almost there, but you're not quite where the 2 points are supposed to be. And when that happens, well, just increasing the slope a little bit might help. So let me once again provide you an example here. Like say I put a point here, 2 up, what does it look like? Maybe 5, 2, 5. That's a point there, and then another point at 0, 1. Now notice how my line goes through that point, and I'll add a label just here. I'll call this point 1, and then maybe this point 2. And let me just rearrange them right there. So notice how my line is going through point 1, but not quite through point 2. And so to fix this, if you're drawing this and you came up with an equation, but your equation doesn't quite go through both points and it's very close like it is here, you can change the slope. Now you wouldn't have a slider, you would actually have a number there. It would say 1.8 instead of m. You can increase the slope by, so if I increase it to 2, notice how it goes right through the point. So increasing the slope makes my line steeper, kind of like going up a steep hill, like the inclination is really high. If I decrease the slope to a number less than 1, in this case look at 0.8, my line gets less steep and it's coming close to being flat. And so that's what increasing the slope does. Now let's look at the other end, which is what happens when your slope is negative. Well, when I have a positive slope, my line goes up to the right. It's going up and to the right. Every time I move to the right, it goes up higher and higher and higher. It's pointing up and to the right. If my slope is negative, notice how my line now is going up, but to the left. So it's going up and to the left over here. So it changes direction. That's what a negative slope does. However, if you increase the slope, even if it's negative, you make it bigger than 1, it still gets steeper and steeper and steeper. And so I want you to understand that the slope has an effect on lines. It makes them steep, and oftentimes it also makes them point in the, I guess what you could say, opposite direction when they're negative. That's the slope. I'll leave it here at 1 for now. Now what about the y-intercept, b? Again, instead of putting a number here, I put a variable so that I can change the value of that variable, and you can see what happens as I change the value. So let's say I increase b to be 2, 3, doesn't matter, but notice how it moves the line up. The steepness of the line doesn't change. It's still the same, it still has the same steepness, but it's moving up. Notice right here where I leave it at 4, that's now the line crosses the y-axis, which is the axis that goes up and down at 4. If I move it to -4, it's going to move this line and it's going to cross that -4 down here. So I can do that by sliding this down to -4 right there. Oh, excuse me, there we go. And so notice how changing the y-intercept just moves your line up and down. Changing the slope kind of like spins the line, increases the steepness or decreases the steepness. Now there's another thing that I want to make sure I talk about, and that's the domain. Let me put here the domain. Recall that we did it, we put in a value here. I'm going to make this number up right now, 3 less than x less than 8, like that, you see? Now what this does, it stops my line at x equals 3. Here's x equals 3, so the line doesn't go past x equals 3 to the left. And then at 8, here's x equals 8, the line doesn't go past to the right. Now let me do the same thing that I did with the slope and the y-intercept. I'm going to put a variable here. I'm going to make up the name. It doesn't matter what you call it, as long as it's none of the variables that I have here, like y, m, x, or b. So I'm going to use a, and I'm going to add a slider. I'm going to actually move this down here. And then again, just another variable. It doesn't matter what it is. I'm going to use c. And I'm going to add a slider. And I'm going to move that down here. Now, what's true when you are writing the domain and it's in this format, x, and then you have this less than and less than. Notice the carets, the little arrows are pointing both to the left. What's true is that for this to work, a has to be at a smaller number than c. It has to. So right now, the reason you don't see a line is because a and c are the same, and they cannot be the same. A has to be smaller. And so let's leave a at 1, and let's increase c to a number bigger than 1, something like, I don't know, 7. Okay? Now, to get the full picture here, I'm going to draw 2 vertical lines. The first vertical line, and how do you draw vertical lines? By the way, vertical lines are lines that go up and down. The way you draw vertical lines is you say x equals. The first vertical line, I want it to equal whatever a is. The second vertical line, I want it to equal whatever c is. And the reason I want to do this is so you can understand, if anything, I can help you picture domain. So let's see here. I'm trying to see. I think there's a way here. Trying to get them to be dashed, and I know there is a way. So what we need to do here, I want to make these 2 vertical lines dashed lines. If you click and hold right there where it says in this little circle, this menu shows up. You can change the color, and I can put dashed right there. Perfect, that's what I want. Click and hold and dash. There we go. And so the purpose here of these lines, the blue line and the green line, is to help us understand domain. The domain here is it's basically, it prevents your line from going too far to the right, so past this green dash line, or too far to the left, which would be past the blue line to the left of the line. And so when we put a domain here, so we have our line that is given by that, and then the domain is this part. When we say that x is going to be greater than a, that's how we read it, or you can read it the other way, which says a is less than x. Well, a is 1, meaning x has to be a number bigger than 1. And that's what we have, that's what we're saying here. This line, we're graphing it only for x values that are more than 1. And 1 is this blue dashed line. It goes right through 1 right here. And then x has to be less than c. Well, c is 7. That means that when we draw our line, it can be only for x values that are less than 7, which is this green dotted line, the green dashed line. And so what we effectively do is we graph this line, but only for x values between 1 and 7. Remember, this number has to be smaller than this number if we are going to keep this notation. So for you, just always keep this notation and make sure that this number is smaller than this number. So if I decrease a, and I want you to think about what's going to happen. If I decrease a, here's a is once again the domain on the left side, what we restrict the domain. If I decrease it, it's going to move to the left, and so this blue dashed line is going to move to the left, and I'm going to graph the line further to the left, and I can see that by just moving this way. You see? I'm decreasing, I'm messing around with this number. If I make it more than 7, then the line goes away because it's not a valid domain. Right here, this is 7.6, so 7.6, and C is 7, and C is 7. And when I use this, format here, A has to always be less than C, and so it's gone. Now if I slide this right here, it moves the right or upper bound on my domain. And so that's how you restrict the domain. Again, I've placed variables here so you can see the effect of changing these values. The slope increases the steepness or decreases it. Let's see how it's getting steep. Until it gets flat, which by the way is a slope of 0. When it gets flat like that, notice how this line is flat now. It's a slope of 0. If I want to increase the steepness, I increase the slope, increase the slope. If I want to move the line up or down without changing its slope, its inclination, I just slide the y-intercept like that. And so, I guess one last thing to note here is to make vertical lines, or I guess to make horizontal lines. Those are lines that go side to side. You would say y equals, and all you need is the number for where you want to cross. You want this line to cross the y-axis. So say I want a horizontal line that's a flat line that goes through 4. I would put a y equals 4. You see? Let me change the color here. Press and hold. Let's make it purple. So y equals 4 is right there. Let's say that I want the purple line, but I only want it from here. I want it to start here and stop here. Basically, start at the blue dash line, stop at the green dash line. Well, I could restrict the domain. I can say I want x to be this blue line I know is 2.9, so that's the blue line, right? So 2.9 less than x less than and I want it to stop here where the green is at. The x value right there is 8.5, which is also the value of c, so I'll put 8.5. And now my horizontal line starts right here at 2.9 and stops at 8.5, which also happens to be the value of a and c, right? If I put an a there and a c there, it works the same way. Now, why does it matter if I put a or c? Well, because if I change the slider here, my purple line gets bigger and smaller as well. That's to make a horizontal line. What if I want to make a vertical line that goes straight up and down? We actually have done them already, x equals. So let's make a vertical line that goes through 6. X equals 6. You see? Let me change the color here to something maybe that we don't have. Let's do orange. And so x equals 6. What if you want to make this line stop? You don't want it to go up forever. You don't want it to go down forever. Well, that's where we actually get into restricting what we call the range. And it's very much like the domain, but instead of having... So let's say that we want it to stop at 2. Start at 2 and go up no more than 5 right here. So from here to here. Well, we will put 2 less than, but instead of x, now we're going to use y less than 5. And notice how it starts at 2, y equals 2, and it goes up to 5. This we call the range. This, when we have an x here, that's domain. When we have a y, it's range. Now I know this is a lot, but what I want you to do is I want you to get comfortable when you're drawing your lines. I want you to feel good about increasing their slope, decreasing their slope, playing around with the domain and the range. And so right here, let me just save this, call it, I don't know, we'll call it slope and domain. Just so that I can have it if I need it later on. And I'll go here to my geometry final. I'm going to open this. And so I have some equations right here, these lines. And let's say that this line right here, notice that I click on it and it highlights over here, it tells me which one it is. Let's just say that it was close to this point, but it didn't get close to that point. So I'm going to make a number up here. I changed it, right? 0.7. So notice that I'm close, but I'm still a little far. I'm not quite going through the points. I know that what I need to do is I need to push the line up, but I need this point to stay where this to stay where it's at. So I need to increase the inclination, which means that I need to increase the slope. So I can try to guess 0.75 and see if that. Oh, I already had a point. 0.75, and you notice how it gets closer. 0.8, and it's closer yet, 0.84, which is what I had originally, and it's right on the mark. If I go too high, 0.9 or 0.95, I start getting past the point. 0.84 was correct. Notice also that right here, this negative 0.2, that's the coordinate of 0.3, the x coordinate of 0.3. It doesn't let me click it. 0.3 is right here, right? Negative 0.2 right there. So it's the x coordinate of 0.3, and then the 2.3, that's the x coordinate of 0.4 right there. And notice that this number is always going to be smaller than that number. 0.7 is less than 2.3. Negative 3 is less than negative 0.2. Negative 3 is less than negative 1.5. And so hopefully this is helping you with your lines. The domain tells the line where to stop, where to start and stop. You want it to start at negative 3, go no further than negative 1.5. And the slope tells you how steep your line is supposed to be. By the way, one more thing to note here is this is a positive slope. That means that my line goes up to the right. So it's pointing up and to the right. and this is a negative slope right here, and my line now goes up but to the left. Like say you were going up the line, you're going to the left, whereas right here if I'm going up the line, walking up the line, I'm going to the right. Same here, positive slope, negative slope. And these are things that you start noticing how they affect your drawing, which is something to keep in mind as you're drawing this. One thing that I could do here, and this obviously right now would be a little bit of a guess, but I can make a line here that it maybe has a slope close to 0. Notice how it's almost a horizontal line. And remember, horizontal lines go sideways, they're flat. So if I do something like -6, notice how it's very close. -6 right there. It actually goes through this point, which makes sense because point 1 has a y value of -6, but doesn't quite go through point 5. And so if I want to increase the slope, leave this point here, I just want to make this line go up a little bit, I can start guessing a slope here like maybe 0.1x. Okay, maybe that's a little bit close to the mark there, but it looks to me like I need to make this a little bigger, 5.8. Very close, maybe 5.9. 5.85. Perfect. You see that right now this was a guessing game. I didn't do any math, but I knew that it was almost flat, a really small slope, 0.1 positive, because I want it to go, as I go up the line, it's going to the right. Now I need to restrict the domain. Well, I'm going to use the x coordinate of 0.1. That's the smaller, that's on the left, right? The x coordinate, and the x coordinate of 0.5. So 0.1 is -1.5. I'm going to put here -1.5 less than or equal to x, less than or equal to, and the x coordinate of 0.5, that's 0.7. And just like that, I made that line really quick. Now, yes, I am asking you to do the math, but you start getting a feel for how lines work. And then we have this line right there. And my drawing is starting to take shape. At least the tie portion of this is starting to look something like a tie.